Alright, welcome back everybody. In this video we're going to talk about numerical integration and how we can find the values of definite integrals on our graphing calculator. We start here with the syntax and how we're going to do this on TI-83, 83 plus, 84, 84 plus series or the TI-89 and 92 series, and where you can find the command for integration on either of those. Those of you who have 84s or 83s with math type, or some of the newer 83, 84 versions that have math type, when you pick the numerical integral command, what will actually happen is a symbol like, the integral symbol will show up here, and there will just be boxes for you to fill in with all of the important information that goes into your integral, and you can literally just take the information as it appears on your paper and type it in. I'm kind of jealous. I wish that I had that capability on my calculator, but I don't. But in essence, all we're going to do is we're going to go to the math menu, and all the way down at the bottom in the math menu you see the fn-int command. If I hit enter on my calculator, that'll bring that out to the main screen. Like I said, for those of you who have math type on your calculator, when you hit that, it'll bring out the actual mathematical notation, and then you can just fill in the blanks from there. But there are four things that we need to fill in here. We need to fill in our function, we need to fill in the variable of integration, and then the limits of integration. So let's go ahead and we'll do few of these just to make sure that we are all getting what we need to here. The first, the integral from 3 to 5 of x squared dx. I'm just going to type in x squared. We're integrating with respect to x, and our limits of integration are from 3 to 5. Now when we do numerical integration, we don't always get exactly what's going on, but we can see here this value for this integral should be 32.6 repeating. And there's the value of the integral. Alright. I'm going to go back and pick Math 9 and bring that out. And now I've got x sine of x with respect to x from -1 to 4. And we get 2.159 as the approximate value of this integral. If you didn't get 2.159, chances are that you are in the wrong mode. You should be in radian mode. I always tell my students calc is rad, so make sure you are in radian mode. Whenever you're dealing with any trigonometric function, we need to make sure we're in the right mode. And for those of you who have 89 or 92 series calculators, the 89 will be very angry if you just type in x sine of x like I did. On there you'll need to separate the x and the sine of x with a multiplication sign. It does not like the implied multiplication when it does numerical integrals, so you want to keep your eye out for that. Alright, again, I'll pull out my fn-int command. And so you see, by doing this, we can arrive at the integral values for, approximate integral values for pretty much any function that we want very quickly and easily. Using this command on our calculator, we end up with 23.770 here for part C. And go ahead and pause the video and try to calculate these values on your own on your calculator and make sure that they jive with the answers that we get. Alright, x to the third plus 3x squared with respect to x from 3 to 7. Oops, missed a comma. And we get 896 for that one. And the last one, x squared minus 3x plus 7 with respect to x from 0 to 4. And we get 25.3 repeating. And so this is a nice tool for us to calculate the values of definite integrals of any function. And this is actually one of the things that you're allowed to do on your AP exam without showing any work. If you have an integral like this on a calculator section, just go ahead and type up the numerical integral and use that to find the value. Alright, next. Example 2. Find the area between the curve y equals x squared minus 2 and the x-axis from x equals 0 to x equals 4. We've already briefly talked about the fact that when a function is a positive curve, the value of the definite integral and the area are one and the same. So if this curve was entirely positive on the interval from 0 to 4, all I would have to do is use the numerical integral from 0 to 4 and calculate that. But, and I'm sure those of you who, are really comfortable with graphing functions know already that this is not the case for this function. The graph of y equals x squared minus 2 actually looks like this. And when we're finding the area from 0 to 4, let's say 4 is right out here, we've got some area that's underneath and some that's above. Now, this area that's below the axis, the numerical integral is going to count that as negative value. Whereas we're trying to find the area, so we want to count it as positive value. So all we're going to do here in order to find this value is we're going to figure out where this intersection point is, the root, and we're going to write up two integrals. We're going to have the integral from wherever that root is to 4 of the function. That we want counted as positive area. My God, my stylus is killing me. That we want counted as positive area. And then the integral from 0 to wherever that root is, which the integral is going to count that as negative value. So in order to turn it positive, we are just going to subtract it away. So now we need to do one more thing, find out where that root is. I already know, but I'm humoring you here. Got our left bound and our right bound. And that root is at 1.41422136 approximately, which, if you know your values, that's actually the square root of 2. And so we're going to use the numerical integral to find these. I'm going to find the numerical integral of x squared minus 2 with respect to x from square root of 2 to 4. And I'm going to subtract away the numerical integral of x squared minus 2 from 0 to the square root of 2. And this tells me the actual area that is between the curve and the x-axis. We get 17.105. Notice that when part of the curve is below the axis, there's a difference between the value of the integral and the value for the area between the curve and the axis. Okay, that's a very important distinction that we need to make. Alright, the last example, example 3, is from a free response question number 1 from the 2013 AP Calc AB exam. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by g of t equals 90 plus 45 cosine of the quantity t squared over 18, where t is measured in hours and t is between 0 and 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. During the hours of operation, blah, 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 the plant processes gravel at a constant rate of 100 tons per hour. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. So what we have here is we have a function for the rate at which unprocessed gravel arrives. That's this function here. To find the total amount of something, when we have a rate function, we are just going to find the definite integral of the rate function over the appropriate interval. So to find the total amount of unprocessed gravel that arrives, what we want to do is we want to integrate the rate function over the time interval that the gravel is arriving, which is from time 0 to time 8. And so to find the total amount of unprocessed gravel that arrives, we're going to go ahead and use the numerical integral function. This problem is, in fact, from a calculator section of the AP exam, and so we would have our graphing calculator to do this, and so it's totally appropriate for us in this context, since it is a calculator section, to go ahead and write that integral out on our paper, and then find the value of it using the numerical integral function. And I don't have to show any additional work other than writing the integral on my page and writing my answer, which is going to be 825.551. Do I have some units here? Yeah, that's going to be in tons, because the rate function is in tons per hour. Alright, and that's the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Alright, so here, that's how we can use our graphing calculator to help us find the value of definite integrals, and we're totally okay with just writing the integral and using the numerical integral to find that. Because, as of right now, we have no idea how else to find the value of this integral. But we will learn. Alright, talk to you guys next time. Have a great rest of your day. See ya.